So we have limitations on the spacing. We memorize, as I said, these formula. Okay, this, and then we check again VS. The first check was VS shouldn't be more than 4 times VC. That was the first check. The second check for spacing that we need to know that if VS is either greater or VS is either less than 2 times VC. Okay, 2 times VC. Okay, which is equal to 1/3 of root square f sub c prime times b web times d is equal, okay? If you multiply 2 times VC, you're gonna get 1/3, 1/3, or 1/3. Okay, 1/3 of root square f sub c prime, because I said VC is 1/6, so 2/6 is equal to 1/3, right? So instead of that, we just memorize these two. It shouldn't exceed 4 VC, it shouldn't exceed 2, in case if greater than VC, or in case is less than VC, okay? In case if less than VC, then the maximum spacing would be half of d/2 or 600 millimeter, okay? 600 millimeter, okay? Beside these two, and or if the VC is greater than 1/3, then it would be, you divide it by 2, this one more 2, so it becomes d/4, and this would be divided by 2 would become 300 if it is greater, okay? If VS is greater than 2 VC, if less than VC, d/2 and 600. If greater than VS, then we divide it once more time over 2, so it becomes d/4, and 600/2 becomes 300, okay? That is how we apply them, okay? This is just to get what you call the maximum spacing for the stirrups, the maximum spacing for the stirrups, okay? We get this and we get this, okay? A VS, and we also have these quantities. Usually, for the maximum, we take the least. We take the least. For maximum, we always take the least. So out of these, 1, 2, 3, 4. Okay, out of these, we take the least. You calculate this, you calculate this, you calculate this, you calculate this, and you always take the least. Usually, the least, the governing one is based on half of the, not all the time, but usually, okay? The governing is based on half of D in case of VC, VS, sorry, is less than 2 times V, okay? We can say 2 times V, 2 times VC. Okay, instead of this, we could say 2 times VC. Very easy to memorize it this way. Okay, is greater. Greater than 2V sub C is less or equal than 2VC. Okay. So that would be the maximum spacing. So you calculate VS, and then you get the spacing calculated. Then after calculating the spacing, you are limited by the S max. Okay. What you have calculated of S, also S is calculated, if you still remember, is calculated based on AV times FYT times D over VS, okay? It's calculated based on. Which one are you going to choose out of these 5 terms? This is also another term. We say that this is the 5th one. So I have 1, 2, 3, 4, and 5, right? Which one are you going to choose? The least one, the one that is the least, the minimum one. Okay, that is for S max. Vale.
مامسا يعني بودو زينوي spacing كابينز يا سامان هي دبي جهة عم بتكتبوا ويا الجري.
Yes, we have 5 terms. Ama 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. It depends. We have conditions for these two. We have conditions for these two. Okay, which one you will choose based on the condition? Which condition is satisfied? This or this? If this condition is satisfied, you go to these two. If this condition is satisfied, you go to these two. Okay. Okay, so now we are done with the calculation. We are done with the design. Now, what is left in case we have specified zones, right? We have specified zone for the design, zone for the minimum that is required by the ACI code. Now we need to know, look at that zone that the ACI code is recommending. We said when phi VC, when phi VC, or sorry, when when VU, you could say VU over phi, okay, is in between the phi VC and phi VC over 2. Phi VC over 2. Okay. When this value is in between, okay, starting from this equal, okay, up to here, okay, up to here, phi VC. It could be covered and could be not covered, okay? We cover it. Usually it's covered. These two sides, we cover them, okay? So this is the, we don't need to be so fussy about, is it equal to phi VC over 2 or is not? We equate it to phi VC over 2 and equate it to phi VC. So these two limits are equated for easiness, okay? For easiness, because it doesn't make any difference if you don't equate it. So when phi between these two zones, what is the difference is we don't calculate S, the spacing. We just choose minimum reinforcement. That means we choose phi 10. Why did we choose phi 10 for the legs? Because this is the least choice that we have, the smallest choice that we have. Out of all the stirrups, I said we have 3 choices. We have phi 10, we have phi 12, we have phi 13, right? The diameter of the stirrups, we have 10, 12, 13, right? Okay? So when minimum is required, you go to choose the least. No point to choose 12 or 13, okay? No point. You can choose, but no point. Why do you choose the largest one? Because it's no reinforcement is required based on theoretical fact. I mean, theoretically, we don't need to have any reinforcement. But ACI code is recommending the use of reinforcement. So why would you go for 12 and 13? Just go for 10. That's the difference between the minimum amount of shear reinforcement that we need to place and the one that we need to design for. The one that you need to design for, sometimes you might choose 12 or you choose 13. Okay, sometimes you choose 12 or 13, okay, because that is designed for that. You need to increase the strength of the stirrups. But over here, the minimum, you don't need to increase the strength because ACI code is recommended. Otherwise, no need for stirrups. In fact, we don't need for stirrups. So we choose the least. That is one thing that we need to understand. We choose the least. Now, how about the spacing? Do we calculate based on this formula AVD? Do we need AV FYT times D over VS? No, we don't need this anymore. We don't need this anymore. We don't need this for calculating spacing. We don't need it. So what do we need? We need this, we need this, and we need, okay, we need these two, and we need these two. These two also we need. Hold on. And we need these two, this and this. Okay, so why we need these and we don't need these? Because minimum. So this spacing would represent, if we choose these two, which is 300 or 0.25 of D, which is less spacing, we don't need that. That is the minimum. So the minimum would be either these, this. So the spacing would be one of these. Which one we will choose for S max? For S max, which one would you choose? Always when you ask for S max, you choose the least. So you calculate this, you calculate this, you calculate this, and you have 600 millimeter. You don't need to calculate it. So you choose the least. Which one is the least? Which one gives you the least amount of spacing? Is it this one? Choose this one. 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 And most likely, again, is this one. Most likely, not always. Not always. Most likely the focus on this one, but not always. Not always. Okay? Did we understand this step? This is for the minimum amount of steel reinforcement. We have 1, 2, 3, 4. Do we check VS? Do we check VS for the minimum amount of steel force? Do we need to check VS? And why? Zina?
بەڵام مامۆستا لە کۆتایی پرسیارچێکی کەینەوە بۆەوەی لە چوار ئەوەندەی VC زیاتر نەبی یعنی.
No, I'm not talking about if now you came that the zone in which you need just minimum amount of reinforcement recommended by ACI code. Do we need
بەڵێ
for VS?
نەخێر مامۆستا پێویست ناکە.
Yeah, we don't need to check for VS. Okay. But there's something that we need to check. It's not the VS. We need to calculate VS. Not to check. We need to calculate VS. Why we need to calculate? Let me explain.
مامۆستا لەوەی مەبەستمان ئەوەی AS minimum بدۆزینەوە یعنی ئەو کاتی.
Yeah, exactly. When shear reinforcement is not needed.
بەڵێ.
Why do we calculate VS? Why do we need to calculate VS? Do you know why?
چونکە کە ACI کۆد داوای کردیە پێویستە ئەمەش حیسابی بکەین ئەگەر هاتوو بە پێی ئەو مەرجەی بوو کە دەمانویست.
No, in fact, let me explain to you. Okay, now we assume that we have this shape of shear force diagram. Okay, this is the shape. So I said within this zone, okay, this zone, we assume that this is our zone, that where minimum amount of shear reinforcement is needed. So this would be 5 VC, okay, and this would be 5 VC over 2. 5 VC over 2. Okay, we agree on this zone, right? We agree that within this zone, minimum. ACI code, no calculation. We don't calculate the stirrups. We just use 510. We are in control of this. We can choose 510. Okay, and then we place the minimum amount and spacing S max, as I explained to you how to calculate S max. We have four. There's 1, 2, 3, 4. You choose the least. You have S max. You have 10 5 millimeter. The only thing we need VS. We calculate VS on what? On what formula? We have, if you remember, that S is equal to AV FY T
over VS.
Over VS. Okay, now the spacing I have, the S max I have 1, 2, 3, 4. So I choose one of them. Let's say 0.5 I choose, and the least was out of 0.5. So once I've got this is calculated. This is calculated because I have chosen 10 millimeter. The phi is 10 millimeter. Fy is given in the question. E is given in the question. So I can calculate this VS. What is the point of calculating VS? The point of calculating this VS from this equation is to add it to VC and multiply both or with phi and then we get the phi VU where we need to start the minimum. So the minimum, we don't start to we don't start to reinforce right from 5 VC. We add VC to it, VS to it. That is calculated based on the spacing, the S max, the spacing S max, and the minimum amount of shear reinforcement in terms of phi 10. Okay. Based on that, we calculate VS, we add it to VC so that we know from where to start the minimum reinforcement. So this would be VS زائد VC, okay, times 5. times 5. So this would represent the VU at which minimum you start to reinforce minimum ACI code requirement. Minimum. Okay? That's why we calculate VS. And the VS, we need to compare it if it is greater or less, because it is already is less than the 2 VC. It's already less than the 2 VC, right?
Yes. That's what moms.
Okay, so that's the only thing that I needed to convey to you. I don't think we have enough time for the example because I have given enough for today. So basically, now we are familiar with the formula and how to use the formula, which zone to design for, which zone not to design for, what kind of checking do we need to carry on or to carry out, what kind of stirrups do we have, how many types, okay? The only thing I also needed to share with you is the design, the shape that sometimes when more than 2 legs is requested, when more than 2 legs are requested. Let me see where I can find it. I think over here, just to let you see the shapes. Aha, okay. So now we have, this is the usual one, the stirrups, the U shape, okay. Same thing over here, but the only thing is not hooked. And the way of hooking is different over here. You can see those are the stirrups. This one, okay. This one, okay. Just the only way, the way they are hooked with the upper reinforcement is different. Is hooking from the outside. This is hooking from the inside, right? From the inside, okay. From the outside, this is from the outside. This is from, how to say this, from the if this is the outside, this would be the inside. From the inside is hook. This is from the outside. The shape of hooking is different. That's the only thing. We have 2 legs in these. 2 legs. So nothing would change in calculation. If it looks like this, or looks like this, or looks like this, or looks like this, then you're gonna have the same calculation. But if you have within this section, you have like these, what do you call these kind of sit-ups? So how many legs? 1, 2, 3, 4. How many legs? So AV is equal to 4 times the area of each leg. The area of each leg. Right? 1, 2, 3, 4. Right? So you see, that is the difference. Okay, if you have in one section, if your beam is like this, okay, the beam contains these stirrups, okay, and the beam is like this, okay, the cross section is square, rectangular, and contains these stirrups, okay. You see, that is the difference that I wanted to show to you. So for today, I think that would be the end of today's lecture. I cannot go ahead, and we will solve problems on next week. Okay, next week. So I take Bale.
ئەمستا پرسیارێکم هەبوو ئەگە بگەڕێەوە سەر پاوەرپۆینتەکەی کە لە کاتی دۆزینەوەی سپیسینگەکان.
Hold on just a minute. PowerPoint. Okay. Share. ئەبینی PowerPoint؟
بەڵێ ئەگە مامستا ئەو سلایدی پێشتر ئەوە بەڵێ ئەوە مامستا گوتت بۆ دۆزینەوەی VS پێویستە یاسای S یەکسانەکەی بە AV FYT BW لەسەر VS وەنە بۆ هابوو گوتت VSەکەی بەو یاسای دەدۆزینەوە. مامستا ئەگەر VSەکەی بەو یاسایە بدۆزینەوە باش، ئەمە چۆن دەزانین ئێسەکەی بدۆزینەوە بە یاسای نوێم یان دێم؟ چۆن بزانین یاسای نوێمیان دێن بەکاربێنین خۆ نازانین VS-ەکە ئایا گەورەترە لە 2 VC یان بچووکترە
Circa. VS, when we design, okay, when we design for the VS, we have VS. VS has to be calculated, Vanya, from the
Vale.
equilibrium equation, which is equilibrium equation is Vn يكسانا بكوي VS زائد VC. From this equation, you calculate. Okay. Now you have two types of checking. One check is VS shouldn't exceed 4 VC. That is one check. Because if it exceeds, the section has to be changed. It has to be given a new dimension, right? And the other one, the other checking is for the spacing, so that we know which term we can use, these two terms or these two terms, right? Out of these four, we also use these two terms, but besides these two terms, we need to know which one of these four we have to use. These two or these two. So we have to another check. That is in case if we design. But when we come to what you call the other one, that we don't design. We just, we don't design. VS is not designed. VS is not designed. VS is equal to 0. Theoretically, VS is equal to 0. When is that? When VU is equal to VS added to VC. Okay, when VU over phi, we say, okay, when VU over phi is equal or less, okay, than VC, or greater or less or equal or greater than VC over 2. Within this range, we don't need to design for this VS. So VS, in fact, if it is equal to VC, is 0, right? If it is equal, if phi VU is equal to VC, so if these two are equal, VS is 0. You don't need to design for it. If the shear force from the load is equal to the strength, of the concrete, then you don't need to design. At this point, you don't need to design. So how about if VU is less than VC? Sure, if equal is not designed for, then how could if less than VC is designed for? So it's not designed for up to 5 VC over 2. So what code recommend is minimum. Okay, the minimum one, we don't need to get the VS from this equation, from the equilibrium equation. But we can get the VS from the spacing equation, because when now you design, when now you give spacing for the minimum amount, which is phi 10, you choose 10 millimeter. You don't choose 12 and 13. You choose 10 because this is the minimum. So you choose 10. Spacing should be the maximum, right? Spacing, you have to choose the maximum. Which spacing? You choose this and this. Out of these four, you choose the least one. Out of these four, you choose the least one. But how can we know the location where to place the first stirrups? Usually the code, as I said, the code is specifying this triangle. Okay, this triangle. The code is specifying a location from when VU is equal to VC up to VU is equal to VC over 2. VC over 2 and VC. This is the location. But now VC and VC over 2, within this zone, you can place the minimum amount of stirrups, right? Within this zone, right? But when you add VC, why not just make use of the fact that when you add VC, you add to its stirrups, VS. So I need to calculate this VS so that I know the location where exactly I start with the first stirrups, so that I don't waste my stirrups only within this zone. I need to have some stirrup that I could make use of the exact amount of shear force, that the stirrups could, the exact amount of shear resistance I will provide with the shear force, where the shear force, exact shear force is located. So that means the shear force, I need to know the location of the shear force where the stirrups could withstand the shear force over there. If I provide VS phi, can I calculate if I have the spacing? If I have the spacing and what do you call the phi. Can I calculate VS based on this formula? The spacing formula that based on which we calculated this, the spacing. Now I have the spacing. I don't need to calculate it. I have AV, FYT, D over VS. Okay? S is calculated based on 1, 2, 3, 4. AV, I decided 10 millimeters. So how many legs? 2. Gone. FYT is given. D is given. Okay? Can I calculate this VS? Yes. Can I add it to VC? What for? Just to know its location on the diagram. Yes, if you add it to VS, if you add it to VC, this would be equal to phi VU. VU over phi. This would be equal VU over phi. Okay, if the diagram is VU over phi diagram, so I know the location where I could place the first reinforcement of the minimum amount. I know the location just to specify the location. So I calculated this VS just to know where I could start my minimum reinforcement placement. تيجي
يعني ما مسامة بس أوي أجر فيو كمان جورة تربولا في إسكا أو كهذا بي في إسو في سيكي هردو كالكوليت كيما بس أوي ونيا.
لا كود سير كود الله لبين أمدو زونا لبيني أمدو زونا مينيمم دعني باش من مينيمم دعنا لبين أمدو زونا لكيو دس فيها كم بالضبط بما بزعم لكيو أتوانم دسي فيها بكم ليرو دسي فيها كي آخر ليرو دسي فيها كي تو في اس كد بودانا في اس زيا بو سودي لينا بني او في اس قوتي هي اقل ليرو دس فيها كي معناه او في اس بخسار أروى لشونك دس فيها بكا في اس كد بخسار نروى ابي نختبر سرو بيجي شو كاقل ليرو داينام ام فيا يكسانا بفي سي اي في اس قوتكي أروى بخوراي اي بو خو استفاده لي كم او في اس دا انا لو شنا لو شنا ودس فيكم نختي زيادة اي في اس كشون كالكوليت كم من سبيسينج اتوانم كالكوليت كم واريا كشي اتوانم بدوزمو با هناك بفايك ايزانم فلو ايكويشن اتوانم كالكوليتي بكم
والله
اوكي
بس ما مسامة بس أوي كد لدو كهاتي دوزينوي إسكا أما في إسكي شون بزانين كبسوكترا لدو في سي يعني جورة لدو في سي.
اي قبل تو في سي كت خوي مينيمم لا في سي او دس بيكا اي تو لا في سي او اي شون قورة ترى لدو في سي شون قورة ترى في اس لدو خوي اللي رودس بيكا
وي لبي جورة تربي
ابي ابدو في سي لا ابي في اس صفر بي يعني في اس نية اصلا في اس نية فتو معناه شيء معناه في اس كت بشوكترا لا صفر يعني بشوكترا لا دو في سي وانيا
كواتها يا سينو يم دبي بكار بين نقدم ما دام هوابي
شلون يا سايتشي
او نويم ها خالي نويم دبي او بكار بي يعني هم كاتي في اس دبي بشوكتر بي اللي سير دو في سي
او بو مينيمم كهر اما بكارين اما او دوانيكا
تو
ام دوانيكا ام دوانا
بلا تو دش
اگه پرسیار نیه توا بو امرو هر اوامه اوكي بو امرو هر اوامه غيابات الخيل شير غيابات شير طبعا جماعات هي يعني درانيان دعمدو لكشري باشتي وساعتك هي انا مو انا سنبناو باب زانن يعني اقام لها مشتكى وني اقام لها فمي اوكي ارى
والله
لا
والله
عند اقام لي ابراهيم
بله.
بشير. Yeah. بناس.
بله.
بنداو. بنداو.
بله.
بهرة.
بله.
شكرا.
بله.
حسام الدين. Yeah. دانا.
بله.
الدين.
بله.
إيدار طاهر.
بله.
رضوان اوكي. رزا اوكي.
بله.
زينة اوكي. جيار
بله.
اوكي. سهند وتيان كهربائي ولا سهند بو وتيان كهربائي.
بله استاذ.
عبد الخالق. عبد الخالق. Yeah. عبد الصمد. اوكي. عبد العزيز.
بله.
ليلى. ليلى.
بله. بله.
محمد فتاح.
استاذ وابزانم عبدالخالق با پیری مربو لبروا لمیتلینگ شو بداری.
اوكي. اوكي. محمد فتاح. يا محمد نور الدين.
بله استاذ.
اوكي. مقداد.
بله استاذ.
يوسف.
بله.
يا رضوان دائم تأخير لي.
بله. والله ما سام روحتم زورت أنا ستيبل بويه.
والله جاري أوتو جاري خد. أريس.
بله.
أحمد.
بله.
توج تأخير هاتي.
بله استاذ.
توج تأخير هاتي أمو.
والله بس او جاري اخي تاخيرات.
لا أمبرو تأخير هاتي دي.
والله دودة قوة بزان معك.